This is for Algebra 1, Unit 2, and we're looking at solving one-step equations. When you think about solving equations, you always want to think about that you are undoing the operation. Okay, so for example, if you look at the first problem there, you have 12 equals x minus 1. You need to figure out what x is, so you need to get all the operations, you need to undo them so that you can get x by itself. So for example, in order to undo, if you have a subtraction, in order to undo that, you would want to add to both sides. So in order to undo subtraction, you're going to do addition. Okay, they undo each other so that you can get the variable by itself. If you wanted to undo, let's say, multiplication. Okay, when you think about what is the inverse operation, well, to undo multiplication, you do division. This will make a little bit more sense when you look at some examples. So let's look at this first problem together. Something that I sometimes usually recommend too is when you're first starting out is draw a line so that you keep the sides balanced. Okay, so we need to figure out what x is. Now you might be able to say or see to yourself, okay, what could I plug in for x so that it equal 12? Okay, so what minus 1 is going to equal 12? You might already see the answer in your head, but the problems are going to get more complex as we go through this, so let's develop a good habits. In order to get x by itself, you need to get rid of the minus 1. So in order to undo subtraction, we're going to add 1 to both sides, because what I do to one side of equation must be done to the other side. An equal sign means they're equivalent. You need to keep it equivalent. 12 plus 1 is going to give me 13. And then negative 1 or minus 1 plus 1 is going to be 0. So therefore x equals 13. Make sure that you know how to check your work. Okay, so I'm going to say if I were to plug in 13 for x, from my original problem, would they equal each other? 13 minus 1 is 12, therefore I know that my answer is correct. Okay, let's look at another example together. Go to number 2. In this case, we have x over 4 equals negative 11. Okay, so we need to think about how can we undo the operation with x so that we can get it by itself. Right now it's being divided by 4. What is the inverse or opposite operation of dividing by 4? Okay, well, you know this. You're going to want to multiply both sides by 4, and that will undo the operation. What you do to one side, you must do the other side. Negative 11 times 4 is going to be negative 44. Do a quick check, make sure that this works. Okay, so I'm going to say negative 44, put in the place of x, divided by 4. Does that truly equal negative 11? Negative 44 divided by 4 is negative 11. Therefore, I know that my answer is correct. Okay, so numbers 3 and 4, maybe you want to try them on your own right now and pause this. I'm going to go ahead and go down to number 6. Number 6 is a little bit trickier, so let's look at that one together also. Okay, so number 6 has r divided by 12 equals, I'm going to put the negative on the top, it doesn't really matter where it goes, negative 7 over 6. Okay, so I need to get my variable by itself, so I need to think about how do I undo division. Well, hopefully you've gotten pretty good at this by now. You're going to want to multiply both sides by 12. Okay, and here's where it gets a little bit trickier. You do have the variable by itself, and now we have to remember how to multiply fractions. Okay, so we have to multiply across the top. Negative 7 times 12 is going to be negative 84. 6 times 1 is just 6. Don't forget to reduce. It looks like I could probably divide the top and bottom by at least 2. Negative 84 divided by 2 is negative 42 all over 3. And I think they both can be divided by 3 again. Okay, so r is going to equal negative 14 over 1 or just negative 14. Let's make sure that we check our work. Okay, so we're going to say, put in negative 14 for r. Negative 14 divided by 12, does that truly equal negative 7 over 6? Now, negative 14 over 12, hopefully you can see you can divide each of those by 2. So you get negative 7 over 6. So yes, they do equal each other. Looks like my answer is correct. Let me see if there's other ones that might be a little bit tricky in this process while you're working through them. Number 9 is also a little bit challenging if you want to go down to that one and work through it with me. If you just want to pause the video and then when you get to that problem you can work through it with me. Number 9, or actually no, number 10 is the one I wanted to look at. No, 8 will be the first problem with that. Sorry. Negative 3 equals 6 minus b. Okay. So I need to get b by itself. Now this is where it's a little bit challenging. It actually, always look at the sign up front. This is a positive 6 or a plus 6. So I'm going to want a minus 6 from both sides. Negative 3 minus 6. Remember, it's like adding the opposite. So it's going to be negative 9. And here's where you have to be careful. We still have a negative in front of b. And it's like a negative 1. So you still want to get rid of that negative 1. So you're going to divide both sides by negative 1. And therefore b equals 9. Let's check to make sure that this is correct. Negative 3, and we're wondering negative, does that equal 6 minus 9? Okay, we know that when we subtract, it's the same thing as adding the opposite. 6 plus negative 9 is indeed negative 3. So we are good to go. Be careful. That's going to show up, number 8 is similar to number 10. Yeah, just similar to number 10 it looks like. So if you have any questions, feel free to ask me.